Okay, on BMQ question 3, so we have these two functions and we're supposed to draw the graphs of these two functions. So this is actually just like curve sketching. So if you draw it, you should get that the first one looks like this. Hang on. Okay, you should look like this. Sorry. Okay, so if you notice, the asymptotes are actually x equals to 1 and y equals to 0. Okay. And but what's that? Y-intercept is actually at 1. Okay, so this is for fx, and the other one, gx, will be with an asymptote of x equals to 2. Yeah. And it will look something like this. So this should be fairly easy to draw, especially if they have a GC. You are also supposed to state the domain and the range of each function. So once you have drawn the graphs, being able to state the domain and the range of each function should be quite easy. For example, for the first one, it's the set of real numbers but excluding 1, and the range is again the set of real numbers but now excluding 0 because you don't have y equals 0. Okay, and for G, the domain is from 2 to infinity. So I don't have any values from x equals to 2 downwards, and the range of G would be from negative infinity to infinity. Alternatively, you could also write this as the set of real numbers. Okay, so that's part 1. Part 2. If the domain of f is restricted to a1, in other words, from some value of x equals to a until some value of x, so until x equals to 1. So the possible range is only from here because 1 is the upper bound. So find the minimum value of a such that gf exists. For gf to exist, what is the condition? For gf to exist, you need the range of f to be within or equal to the domain of G. So if you are restricting from a to 1, this is my range of f. My range of f here is from 0 to infinity. If I only think about from negative infinity to 1, let's say for f, just the domain, then my range, notice if you look from the graph, would be from 0 to infinity, but I need it to be within my domain of G, which is 2 to infinity. So the smallest value I can have for my range is actually equals to 2. Which means that the smallest value of A must be when y equals to 2 in that case. So I need to solve for this A here. Okay, so I have A equals to half. Notice that I did not need to include, because this is a round bracket, I'm not including the value of A. So when I have A equals to half, fx equals to 2 and is non-inclusive as well. So now my range of f becomes exactly equal to my domain of G. So therefore my minimum value of A is A equals to half. Okay, so remember the key thing is composite functions for GF to exist, my range of f needs to be within or equal to the domain of G. So to reiterate, my domain of G is 2 to infinity. I need to find an A such that I limit my range of f to 2 to infinity. And so when I find it, I get A equals to half. Okay, so I'm supposed to define GF and find its range. Now G of f of x, so it would be G like that. Okay, which means I actually have this going on. X minus 2 plus. Okay, simplification. So GF, the function GF, is such that x is mapped to ln 2x minus 1 over 1 minus x plus 1, with the domain x has to be within half to 1. This is from part 2. Okay, they ask for the range of GF. Now if you have your domain of f as half to 1, that will mean, let me write this down, the domain of f is from half to 1, then your range of f is 2 to infinity, which is also your domain of G, which means that your range of GF is equals to the range of G, and it is actually just negative infinity to infinity. Okay, so your domain is from half to 1 and your range is from negative infinity to infinity.